Hello, AP Physics 1 students. I'd like to take a look at problem 2 again, and we're going to take some notes about the situation involved here. In problem 2, we had the bucket in part A just sitting at rest on the ground, and we calculated the normal force. Now, we didn't really get into detail about it because it's a pretty simple problem, but clearly the bucket's not moving, the velocity is 0, and it's not changing what it's doing, so the acceleration is 0, and that means the net force is 0, and so, of course, the weight pointing down is counterbalanced by the normal force up, and there's normal force because the bucket is on a surface. So in this case, the normal force is just supporting the weight, preventing it from changing what it's doing. It's at rest, it stays at rest. But then we look at letter C, and letter C, we had the bucket moving, but is going at a constant speed. Of course, we know if it's going at a constant speed, that means the acceleration is 0, as long as it's moving in a straight line, which it was. And if the acceleration is 0, the net force is 0, and so in this case, the tension was equal to the weight. And so we talked about this in class, so the tension was sort of playing a similar role to normal force, even though it's not the same thing because the tension comes from the rope, whereas the normal force came from the surface. But in both cases, we have the situation where the net force is 0, the acceleration is 0. One lesson we can learn from this is that just knowing acceleration is 0 or net force is 0 doesn't actually tell us what the object is doing. All it tells us is that the object is not changing what it's doing. Both cases, though, are known as the situation as equilibrium. And so in our notes, let's talk about the state of equilibrium versus not equilibrium. There's no good physics word for not equilibrium. It's not disequilibrium, it's just not equilibrium. And the definition of equilibrium is sigma f equals 0. When we add all the forces together as vectors, there's no net force. And so if the net force is 0 for equilibrium, for not equilibrium, well, just that the net force is not 0. That when you put all the forces together as vectors, something is left over. There is a net force. So of course this directly relates to acceleration. If the net force is 0, that means the acceleration is 0. That's equilibrium. Not equilibrium, you might guess, it just means the acceleration is not 0, right? That there is an acceleration. So some students like to see with symbols, other students like to see with words. In this case, if the object is non-equilibrium, it is accelerating. What does that mean for equilibrium? It means it's not accelerating, right? That's really all it means. It's really, any of these columns here, really all, they're saying the same thing, just in different ways. Some students like it with the symbols, some students like it with words. So going back over to the not equilibrium situation, if it is accelerating, well then what could it possibly be doing? Well, maybe you just want to pause the video and think that through. Well, hopefully you know there's 3 things it could possibly be doing. If it is accelerating, it's either speeding up, slowing down, or changing direction. Or maybe even doing a combination of these things. In other words, the velocity is changing, right? If it is accelerating, if it's not equilibrium, something about its motion is changing. Speeding up, slowing down, changing direction, or some combination, the velocity is changing. So what does that mean for the state of equilibrium? Well, that just means it's not doing any of those things, right? You don't have to write it again if you don't want to, but it's not speeding up, it's not slowing down, it's not changing direction. That's equilibrium. So does that mean it's not moving? Well, as we just saw with the bucket, maybe it is, maybe it's not, right? It may be moving only if it's moving at a constant velocity, nothing changing, right? Acceleration equals 0. However, of course, it could be at rest, right? If it's at rest and not changing, that's still equilibrium. So there's words for these different types of equilibria, right? If an object is moving with a constant velocity and it's in equilibrium, so that the acceleration equals 0, we call that dynamic equilibrium. If instead the object is at rest, the acceleration equals 0, we call that static equilibrium. So again, just knowing an object is in equilibrium, just knowing the acceleration equals 0, just knowing the sigma f equals 0 is not actually telling you about the motion, it's just telling you the motion is not changing.